simple pendulum experiment. From simple pendulum, just what is simple pendulum? First one, here, simple pendulum, when a heavy point mass, is suspended by an inextensible string. Heavy point mass is suspended by an inextensible string. This point mass is called, it's a bob. Okay, so point mass, and heavy point mass inextensible string means, for an inextensible string, the string which is fixed to a fixed support, this point mass, whatever the shape, its center of mass from here. So this is generally, this is what, it's a center of mass. The length from here to this point is called effective length. It's a effective length. Effective length is what? L effective. Okay, so this is what, it's a center of mass. Now when you apply some external force on this bob, then what happens? It displaces. The angle should be very small. Angle is very small, and it undergoes into the oscillations. The fixed position, the fixed point to which the bob regains to its original position is called mean position, standard position, or equilibrium position, which comes to its original position. So who is bringing the bob to come to its original position? What is that? It's a restoring force. It leads for what? It's a restoring force. Okay, so from this, fixed support is taken. Okay, and from the vertical, so this is what vertical, like I'm taking as vertical here. And next one, a bob is displacing from here to here, like this is the case. Okay, so which makes, first one, its position is this, so position is this, displacing from here to here on this curve. Okay, so which makes an angle from this point, which makes an angle theta with a vertical angle made by this. This we know, it's a effective length. Effective length is what? From here to here, from center of mass to here, is called L effective, which known as effective length. And for better understanding, and even for the further also for the problem solving, you will see that this is what actual position from here, one reference line. Next one is what? Another reference line. Okay, so you may get the questions from this based on simple pendulum. First one, our concept is what? Just only to discussion about is what? To discussion about it's a time period. So I am including the things with the questions which are there which will come into this one based on this. What is the velocity at this point? If it has the velocity at this point is v, what is the velocity at this point? Okay, so that velocity is what? What is the height raised in collisions? Okay, perfectly inelastic collision. A bullet is fired, embedded into this one, rises to a height. Okay, what is the height raised by this? Okay, so like different type of questions will be in vertical circular motion. Okay, in vertical circular motion, if it has to complete like one circle, yes, so the velocity, what will be the minimum velocity? Under root of 5g r, we are given that. So if it is less than that, what happens this? Like different type of questions you will get from this. The basic information is what? Simple pendulum. Simple pendulum is what? It's a heavy bob, point mass, where if you take as a bigger one, the center of mass is concentrated at its center. Okay, so now we can talk on this. Center of mass is this, I am talking about its location of center of mass only. And let us come to the situation now. What is the time period of this? What is the time period of simple pendulum? Okay, so time period of simple pendulum, first one, from this position, this is what I'm talking as, it's A, and this one is what it's a B. Yes, so it's a very fundamental thing to discussion about. Just what its weight is, what weight is like exactly, so center towards the center of earth, like this is the weight. This weight is resolved into the two components. Okay, it resolved into the two components. So one is like this, right? Next one is like this. Yes, so this is what the thing. Okay, ma. So this is exactly here. I can say you that. So exactly along with this. Okay, like parallel to this one. So its weight is what? Now come to the general situation. What is the weight of this bob? mg. It makes an angle theta. Here also will be what? Theta only. Correct? Wherever theta, when you resolve a vector, which you are resolving weight, where what is the direction of weight? Weight is towards the center of the earth. Okay, this is not along with the axis, it is there in the plane. Then what to do? I should resolve into the components. The components are what? One is what? mg cos theta. Next one is what? mg sin theta. mg sin theta. So when you apply some external force on this, okay, so this here mg sin theta, for the first condition I can say this one, mg sin theta, okay, acts like what? Which is bringing to its original position. That is what mg sin theta. mg sin theta is called what? Restoring force. Restoring force always opposite direction to its displacement. So mg sin theta is what you say? It's a restoring force. It's a restoring force. So what is the restoring force? Restoring force F is equals to minus mg sin theta. F is equals to minus mg sin theta. You know all the things. So minus indicates what? It's a opposite direction to its displacement. Okay. So next one here. First one, F is equals to minus mg sin theta. The angle should be very small. When you're talking about this oscillations, what type of oscillation is this? It's a linear oscillation or angular oscillation. Definitely it's a angular oscillation. Whatever the oscillation, the angle should be very small. Okay, angle should be very small. So when angle is very small, okay, theta is very small. Theta is very small. Then what? Sin theta is similar to what? It's a theta. F is equals to minus mg sin theta means what? It's a theta. Okay, so F means what? It's a F. Okay, this is what is my first condition. Now from here to this position to here is called what? It's an arc, correct? From here to here is what? It's an arc. Arc length is what is it? It's a x. So that arc length is equals to arc length x is equals to arc is equals to what? Radius into angle. Radius. Okay, it's a radius into what you say? It's a angle. So x is equals to radius is r, angle is what you say? It's a theta. X is equals to r into theta. What's your r? R is what you say? It's a L, correct? It's a L, the length of this. Okay, so now you can talk on this. F is equals to from here, then theta is equals to what you say? X by L is the theta, correct? F is equals to minus mg, okay, into theta is what you say? It's a x by L. What is F? So it's what? You have minus, correct? It's a minus. Okay, so what is F? F is equals to what you talk? M A. So is equals to minus mg by L into what? It's a x. Okay, so m and m cancel. Yes, A is equals to minus g by L into what? It's a x. What is A? Acceleration. What is the acceleration of particle executing SHM? Simple harmonic motion. A is equals to minus omega square x. Okay, so this is what here I can write on. This is what it's a from here minus omega square x is equals to minus g by L into x. X cancel, minus minus cancel. Omega square is equals to g by L. Omega is equals to under root of g by L. What is angular velocity? What is angular velocity? When the particle, when simple pendulum executing simple harmonic motion, okay, so omega is equals to under root of g by L. G stands for acceleration due to gravity, but that acceleration due to gravity in now onwards we call as effective acceleration. What do you say that? Effective acceleration. L stands for its a length. So omega means what? It's a 2 pi by t is equals to under root of g by L. Then take it as reciprocal. T by 2 pi is equals to under root of L by g. Okay. T is equals to, we can write it as t is equals to 2 pi square root of L by g is the relation. The time period of particle, the time period of simple pendulum which is executing simple harmonic motion. So that's what? T is equals to what is the formula? 2 pi under root of L by g. Okay. So now just we have completed time period T is equals to 2 pi square root of L by g, where g is called effective acceleration. Okay. Effective acceleration. So effective acceleration changes. This is what denoted by G effective. Okay, it's what G effective. And T stands for it's a time period. T stands for it's a time period. Yes. Now for the first condition and the first one, very first condition I'm talking on, this is what type of at a very basic level, like a fractional error, percentage error type of questions like so. Then T as a time period increases, as time period increases means what? When length increases, time period increases. When G decreases, time period increases. So from this, T is directly proportional to what? Directly proportional to length. So T is proportional to L to the power of 1 by 2. Okay. So then what? If you want to write it's a fractional error, delta T by T into 100 is equals to half into, what do you say? It's a delta L by L into what? It's a 100. Yes. So in terms of G, acceleration due to gravity also. So when you are moving to certain height, mountains, okay, so the value of G decreases. So the value of G decreases means what? What is the expression for the G? G is equals to, for the small heights means what? GH is equals to what we written? G times of 1 minus 2h by R. Okay. So like we can talk also for the second one is T is proportional to 1 by square root of G. T is proportional to G to the power of minus 1 by 2. So we can also say delta T by T into 100 is equals to, so we can write minus 1 by 2 into delta G by G into what you say, it's a 100. Okay. So this is one case for the time period T is equals to 2 pi square root of L by G. So for the fractional changes and percentage changes or lose or gain means what? We have the methods which is less than 5% and next one is also more than 5%. Yes. So just it's a basic information. Time period T is equals to what is the condition? 2 pi square root of L by G. G stands for what? Effective acceleration. Concept of effective acceleration. Concept of effective acceleration in a SHM. Okay. So what is the effect of acceleration in SHM? What is the concept? So effect of what is that? Effective acceleration. Effective acceleration is what? T is equals to 2 pi under root of L by G effective is the case. What type of questions will be asking on this? First one, you need not to derive all the cases. Just you can go to remember on this, the things which will be repeated again and again. Okay. So, for first one is about case 1 I am talking on this. This is case 1. First case is what? Okay. So, for example, a simple pendulum is suspended in a lift. It is suspended in a lift. Okay, this is the first case. So there is a lift. Yes, like here is the lift. So pendulum is here. This is the pendulum suspended. Lift is at rest. First one, Roman number 1. Lift is at rest. Lift is at rest. Okay, lift is at rest. So this is for the inertial conditions when you are looking from outside. So then what? Lift is at rest means what? Here, then what is a effective acceleration? G effective is equals to, what do you write on this? G effective is equals to G effective is equals to, what is the condition? G only, because it is at the rest. Why? Acceleration is what? 0. So then what is the condition? T is equals to 2 pi under root of L by G effective. So G effective. So what is the G effective now? So G only. Then what do you write? T is equals to 2 pi under root of L by G is the first relation. So the lift is at rest. Effective acceleration is what? Acceleration equal to 0. G effective is equals to what? It's a G. So for the second case I am talking on this. If lift is accelerating, okay, upwards, accelerating upwards with an acceleration A. So what is the G effective? G effective is equals to G plus A. Accelerating downwards, G effective is equals to G minus A, Newton's laws of motion. Yes. So the time period T is equals to, what you write? T is equals to 2 pi under root of L by G. This will be 2 pi under root of G means what here? G effective, right? So then 2 pi under root of L by, what is this? G plus A. Okay. So next one for the third case, if you write on this one, so lift is accelerating downwards. Lift is accelerating downwards. So which is accelerating downward direction. So what is the G effective now? G effective is equals to G minus A. G minus A. So with what acceleration it is moving downwards? With A. So what is the condition? Moving upward means what we said, ma? G effective is equals to G plus A. Accelerating downwards, G effective is equals to upward means what? G plus A. Downward means what? G minus A. So then time period T is equals to, we can write 2 pi under root of L by G minus A is a case. This is what it's a time period. T is equals to 2 pi under root of L by G minus A. G minus A is what it's a effective acceleration when the lift is accelerating downward direction. So for the fourth case, I'm talking on this. If the lift is moving with a uniform velocity. Uniform velocity means what? It's a constant velocity. Okay. So if lift is moving means what? Either upward or downward. Anyone you can take it as moving with uniform velocity. Uniform velocity. So uniform velocity means what? Acceleration A is equals to what? 0. V is equals to constant, no. So what is the acceleration? 0. So if you take about, it's a downward direction. If the lift is what? It's a downward direction. But if it is downward direction, what is the condition? T is equals to 2 pi under root of L by G minus A. So G minus A, what is the A? 0. So what is the condition now? T is equals to 2 pi under root of L by what? It's a G. So if it is moving upward direction, T equal to 2 pi under root of L by G plus A is 0 only, no? Okay. So even the lift is moving upward, if it is upward, so then T is equals to what you say? 2 pi under root of L by G plus A. So what is the A? 0. Then what do you say now? T is equals to 2 pi under root of L by G is the time period. Sir, if the lift is moving, so the string is cut off. String is cut. It's moving like a free fall. Okay. Next one for the fifth case, for free fall of lift. Free fall of lift. If it is freely falling, if any body is dropped from certain height, it is under the case of freely falling. Freely falling means what is the acceleration? A is equals to G. Okay. So free fall means what is this? A is equals to G plus G. Correct? A is equals to G. G stands for acceleration due to gravity. Then T is equals to, we can write 2 pi under root of L by downward. Downward means what? G plus A or G minus A? G minus A. A means what? It's a G. G minus G, 0. So then what do you say? Then T is equals to 2 pi under root of L by 0. So which means what? It's a something by 0 is what? Infinity. So what is the time period? Infinity. Time period infinity means started from here. It has to come from year to year one oscillation. If it completes one oscillation, time period is what? T. It is not completing one oscillation. It is not oscillating. It is not oscillating means what? What is the time period? So it's what? Infinity. Okay. So you wait how many days also, the thing will be same. So then T is equals to, what is the T? T is what is it? It's a infinity. Second case I'm talking. Simple pendulum. Simple pendulum is suspended. It is suspended in a moving truck. Moving truck. Simple pendulum is suspended in a moving truck. Just to imagine, there is a truck. Okay, so is a truck, it has to be moving on the horizontal surface. Yes. Now, this is a pendulum. Just to imagine, it's fixed here. Okay, here is a fixed support. This is the vertical. A pendulum, when it is moving with an acceleration A. Whose acceleration? Acceleration of the truck. So where are you? So this is what pseudo force is acting on this non-inertial frame. Okay, it's what under the non-inertial frame of reference. So pseudo force will be acting on this. So pseudo force is acting means what? Which makes an angle is what? What is the angle? It's a theta. So this is what? It's acceleration. No, in opposite is what is it? It's a ma. Its weight is what? mg. Its weight is what is it? It's a mg. Correct. So what is the effective acceleration? Effective acceleration means what? Just if you can use it as it's a parallelogram law condition, like okay, parallel to this one draw a vector, parallel to this one draw a vector. This will give what? It's a resultant. Correct. It's a resultant. So what is the angle made with the vertical? This theta. This one also what is it? It's a theta. So this is what mg ma. So this is ma. This one also what? ma. Correct. Yes. So this from this case here, like is a case. So it's what? Theta. It's what you say? It's a mg. This is what? It's a ma. What is the resultant? Hypotenuse. Okay. Hypotenuse square is equals to r square is equals to mg whole square plus ma whole square. Correct. Okay. So this is what? mg effective square. Correct. G effective net force I am finding this one. mg effective square is equals to mg whole square plus ma whole square. M common cancel. Then what is this? G is equals to under root of G effective is equals to under root of G square plus what? It's a square. G effective is equals to square root of G square by G square plus A square. So what is the time period now? T is equals to 2 pi under root of L by what? G effective. T is equals to 2 pi under root of L by what is the G effective? Square root of G square plus A square. It's a G square plus A square. So when the truck has to be moving, when the truck is moving on a straight line path with an acceleration a pendulum is suspended on the truck. The pendulum, then what happens? It is moving back forward means what? Pendulum moves what? It's a backward direction. It makes the oscillations. So what will be its time period? To know its time period, we should find its effective acceleration. What is the effective acceleration? It makes the oscillations like this. It makes the oscillations. Okay. So then what? What is the G effective means what? Before that one, what to find? It is under the case of what? Pseudo force. When it is moving, you know the cases of the pseudo conditions means what? Non-inertial frame of reference. Okay. So its pseudo force is acting ma. So its weight is what? mg. So what is the G effective? Under root of G square plus A square. So the time period T is equals to 2 pi under root of L by G effective. Curvature for the case 3. That's what? Curvature. On the curvature. Okay. On the curvature. So truck, it is moving like this straight line. So what is this? This is the truck which is moving with an acceleration A. Okay. So it has to take a turn on the curvature. It has to take a turn on the curvature. So this become as what? Correct. It's a center, na? Isn't it? It's a center. What is its radius? It's a R. So which force comes into play when it is moving like this on the circular path? Central force. Okay. So central force. Which one is this? It's a central force. Central force. What is the formula just now we written? G effective. G effective is equals to under root of what is the condition? G square plus A square. A stands for what? AC. AC stands for what? Centripetal acceleration. Do you know centripetal acceleration? AC is equals to V square by R according to your requirement. So otherwise, in place of V, what to write? R omega. Okay. So I can also write in place of V, what do you write? R omega. AC is equals to R square omega square by R cancel. AC is equals to R omega square. You can use this formula or this one. AC is equals to V square by R. AC is equals to, what is the condition? R omega square. Now, so what is the G effective? G effective is equals to square root of G square plus A square. A square means what? What is the A square? So, yeah, V square, correct na? So it's what? It's a V square by R whole square, correct? In place of AC, what to write? G square by V square by R whole square. A time period, if you want to write about the time period, T is equals to what? 2 pi and a root of L by G effective. What is the G effective? Square root of G square plus V square by R whole square. V power 4 by R square. Same, the truck has to be moving. Okay, it has to move on what? Curvature. So curvature means what? Central force comes into play. Central force comes into play means what? This acceleration is called what? Centripetal acceleration. Centripetal acceleration. Okay, it's what? Centripetal acceleration. Okay, so this is what? Centripetal acceleration. AC is equals to, what do you say? It's a V square by R. Okay, so next one. So for the case 4th, I am talking on this. The 4th case is what? Simple pendulum is made to oscillate in a liquid. Simple pendulum. Okay, so simple pendulum is made to oscillate in a liquid. Okay, in a liquid is a situation. So this comes under what? Fluids. Force of buoyancy. Just what I'm talking about, a condition is what? This is a fixed support. Here is a pendulum. Yes, just I made it as a container here. Okay, this is what? Liquid. Yes, it is making the oscillations. Very, very important situation. The density of this one is what? Just to take it about density of body, rho B. Liquid is what? It's a density of liquid, rho L. What forces comes into play when it is making the oscillation in the liquid? Force of buoyancy is what? Upward. Weight is what? Downward. So the net force is equals to F is equals to first of all, to take about its free body diagram. Force of buoyancy. Next one, its weight is what? Weight. Force of buoyancy, and next one is about weight. Okay, so weight, this is what? Force due to what? It's a gravity. F net is equals to Fg minus due to force of buoyancy. What do you know about force of buoyancy? Force of buoyancy means what? The force acted by the liquid on the body. Force acted by the liquid on the body. So this is what? From this I am talking on this. F is equals to, it's a mg. Force due to gravity. What is this? Towards down. What is that? It's a mg. So mg minus force of buoyancy. Okay, mg belonging to what? Weight. Whose weight is this? Weight of body. So what is the mass? Mass is equals to what? Density of body into volume. Into what? It's a g, correct? Okay. Force of buoyancy is what? Force of buoyancy is what? The mg means what? Density of liquid volume inside the liquid into what it's a G. Again I'm talking. When you speak about this force of buoyancy, nothing but you're talking about the liquid. What portion is immersed in the liquid? That is what it's a force of buoyancy. It's a completely immersed, right? What is the volume of this body inside the liquid? V only, na? Are you getting? Inside, for example, half part only immersed. So what will be the now force of buoyancy? V inside, V by 2. Getting okay? Okay. So this is what F is equals to density of body, volume into G minus density of liquid. Volume inside is what? It's a V only into G. Okay. So this is equals to density of body minus density of liquid into Vg. Is okay. So V stands for what? Volume. G stands for what? Acceleration due to gravity. What is the force? Net force. It's a net force. Net force means what? MEA. A is what? Effective acceleration again. So it's what? Mass is what? Density into volume. Density into volume. Okay. So mass is equals to the effective acceleration. Mass means what? Density into volume. Into what it's a? G effective is equals to what? Density of body minus density of liquid into Vg. The question is about density I written. Whose density is this? Body density, liquid density. When you talk about the liquid density, when you are talking about what? Force of buoyancy. Force of buoyancy. What is the net force acting on the body? Mean this will be what? It's a body only, na? What is the volume inside? Same, right? Getting? So this is what? Density of body. G effective is equals to density of body 1 minus density of liquid by density of body into what? It's a G. This cancel, right? Okay. So what is the G effective now? G effective is equals to G times of 1 minus density of liquid by density of body. Such a very important relation. A body of mass density rho b is made to oscillate in a liquid. The liquid may be water or anything. If water, there also different densities will be given in the question. If it is given, okay, density of liquid is what? Rho L. Okay, so due to this, all the cases we proved this one. Finally, what's your answer? Effective acceleration is equals to G times of 1 minus density of liquid by density of body. How to remember? Which is there upper? Liquid, na? 1 minus density of liquid by density of body. So, effective acceleration. Effective acceleration. G effective is equals to G times of, it's a G times of, so this is 1 minus density of liquid by density of body. Do you know that what is specific gravity of a liquid? Specific gravity, just for your kind of information, specific gravity is what? Sg. I am writing this. This is equals to density of body by density of what? Liquid. Specific gravity is equals to density of body, okay, rho b, density of liquid rho L. Can you rewrite this equation? G effective is equals to G times of 1 minus 1 by density of body by density of liquid. This is equals to G effective is equals to what is a G times of 1 minus 1 by specific gravity is one more relation from the same expression. Now the time period. Sir, what is the time period? The time period is what? Time period T is equals to, first one, 2 pi under root of L by, okay, G effective G times of 1 minus density of liquid by density of body when it is making oscillation in a liquid. In terms of specific gravity, T is equals to 2 pi under root of L by G times of 1 minus 1 by specific gravity is another relation. Like this. In the situation when body of density rho b is making oscillation in a liquid of density rho L or rho anything, something value would be mentioned. So what is the G effective? Just don't go for any derivation exam. Directly you have a condition. What is there? G effective is equals to G times of 1 minus density of liquid by density of body. In terms of specific gravity, G effective is equals to G times of 1 minus 1 by specific gravity. What is the time period of oscillation? 2 pi under root of L by G effective. G effective means G times of 1 minus density of liquid by density of body. T is equals to 2 pi under root of L by G times of 1 minus 1 by specific gravity. Next one. If a pendulum has a charge, okay, pendulum has a charge, what is the time period in a electric field, in external electric field? Just you take about for better understanding very clearly, ma. So this is what I'm taking about. This is electric field. Electric field is downward or upward? Downward. Yes or no? So electric field is away from positive charge or towards positive charge? Away from positive charge. Okay? Yes. So now this is what here for example is a fixed point. This is the bob, is a fixed point which makes an angle theta. Its weight is what? Mg. Its weight is what? Mg. What is the direction of electric field? Downward. And what is the formula for electric field? You know, electric field is equals to F by Q. F is equals to what? E into Q. Do you know this thing? F is equals to E into Q. F means what? MA. MA is equals to what? E into Q. Correct? A is equals to what? EQ by M. What is the acceleration of the bob? What is the acceleration of the bob in the electric field? A is equals to EQ by M. E stands for electric magnitude of electric field. Q is the charge. M stands for what? Its mass. So what is the direction of this? In downward only, no? So then what? G effective is equals to G effective is equals to. Okay? First one is what? Downward. What's there? G plus A. Correct? Mg and field force due to this field also downwards. So G effective is equals to, what do you say? G plus A means what? It's a EQ by M. So what is the time period? T is equals to 2 pi under root of L by G plus EQ by M is the condition. This is the time period of oscillation. If the field is downward, can you guess that? If the field is upward? Minus. Okay. So next one. Similarly, when field, which field? Electric field. is upward, when the electric field is upwards, then time period t is equals to 2 pi under root of L by what? G minus EQ by M. This is what it's a time period. Okay, so time period of oscillation when the field is what? It's a downward. Okay, so this is what mg. So downward means what? What is the condition? mg plus EQ, correct? Upward means what? mg minus EQ. So mg minus EQ means what? G minus EQ by M. So this is what? It's a G plus EQ by M. So making oscillation in a electric field. Seconds. Okay, pendulum. What is seconds pendulum? Seconds pendulum means what? The pendulum which is making oscillation. So what will be its time period? What is its time period? 2 seconds. Okay. The pendulum whose period of oscillation is 2 seconds. A period of oscillation means what? T is equals to 2 seconds, correct? So T is equals to 2 seconds. Okay. So what is T now? T is equals to 2 pi under root of L by G. What is T? Say 2 is equals to what? 2 pi under root of L by G. 2 and 2 cancel. This is 1 is equals to pi under root of L by G. Squaring on both sides. So 1 by pi square is equals to L by G square. What is the value of G? 9. It's not G square, no? It's a. So this is what it's a G. So 1 by pi square is equals to L by G. What is the value of pi? 3.14. It's a 3.14 into 3.14. Nearly 10. G value nearly 10. So can I take about this one? It's a L is equal to similar to 1 meter. To make the oscillation, it has to be completed one oscillation. Started from here and from here to here 2 seconds. What will be its length? 1 meter. What is the length? The length of the pendulum should be what? It's a 1 meter. Okay. So for seconds pendulum, so time period is equal to what? 2 seconds. Length must be is equal to what? 1 meter. Time period is equal to 2 seconds and the length must be is equal to, it's a 1 meter, nearly equal to 1 meter. That's it.